Hey guys, Ivan from Reactive Network here, and welcome to the second workshop dedicated to our Build with Reactive Network program. So you might have seen the previous workshop where we talked about the program itself, the judging criteria, what are we looking for in the projects. So if you haven't seen it, you might want to take a look because all the stuff about the program is there. And today we are going to talk about some more technical things. I will share more examples. I will show code. I will explain some concepts. And as always, I will answer all the technical and non-technical questions. So first of all, if you watching the recording, you can still ask the questions in the chat. You can see the link to our developer chat in the description of this video. And if you're watching us live, thank you for joining us today. And you can ask the questions in the chat and I will answer them in real time. So let us start with some basic concepts. Today, we'll be talking about the following things. First of all, I'll remind you what the Reactive Smart Contracts do. We'll talk about some use cases, potential and existing ones. I will show again the scheme of the one-step swap because it's pretty explanatory and explains the concept pretty well. It shows what a reactive contract does, a callback contract does, so that's a good one. We'll talk about the stop order. I will show the code as well. We will also talk about the dual state of Reactive Smart Contracts. And we will deploy some existing examples that you can find in our repository. I'll show how it works. Basically, it's all there. You can just follow the instructions. I just wanted to do it live so that you can see how to deal with it. And also, we will talk about how to build your own reactive workflow. Okay, first of all, let me remind you what Reactive Smart Contracts are. So Reactive Smart Contracts allow reacting to on-chain events with on-chain actions on the same or another chain. So I like the analogy of on-chain if this and that, or bots, but bots are centralized and Reactive Smart Contracts are decentralized. So you can do all the stuff that was available from off-chain before that. You can do it on-chain without managing the keys and without some of the security risks. So Reactive Smart Contracts enable the following things. So first of all, they enable automation because you can build automations on top of your own or some other smart contracts by reacting to some events on them with transactions, with calling the functions on other smart contracts. Also, you can add cross-chain functionality to existing setups with Reactive Smart Contracts because, as mentioned earlier, you can react to event on chain A with actions on chain B, for instance. And then it also enables modularity because you can react not only to your own contracts, but to third-party contracts as well. And this third thing actually differentiates us from the solutions that existed earlier, basically GMPs or cross-chain tools, because for most of them, you will need to actively send messages from the origin contract or origin chain to the destination, whilst with Reactive Smart Contracts, you can build your reactive setup on top of existing smart contracts, on third-party smart contracts, without the need to alter the code. So you can add modules on top of existing dApps as well. And all of that in a decentralized manner, obviously, because these are smart contracts. Basically, they are EVM, they are Solidity, very similar to Ethereum smart contracts, just with a few tweaks. Okay, yeah, sorry for the white line, something wrong with the slides here, but anyway, let me remind you the basic scheme. So the yellow origin smart contract on the left is the one to events of which we react. So some event happens there when a function is called. Then the reactive smart contract, in the middle reacts to this event. The react function is being called automatically. So it processes the data, it executes some logic with which is depicted here with 3 dots. So you can check any conditions, you can calculate whatever you want, and then in the end of this thing, you emit a callback event, which is a keyword which executes the callback to the destination smart contract, which might be on the same or different chain. So here, for instance, the origin smart contract is on Ethereum network, and the destination smart contract is on Polygon network, and the middle one, the reactive smart contract, is obviously on Reactive Network. Okay, so to put it in the context of practicality, let me mention some of the examples. So one of the examples is one-step swap, where you can replace the traditional two-step swap, where you need to approve the funds first, and then you do the actual swap. So you need to sign several transactions in your MetaMask. You can automate this process so that the user will need to sign only one transaction, the approved transaction. They will approve the funds to be spent by the our special callback contract, and then all the rest will be done automatically by Reactive Smart Contract. Also a stop order, which we will take a look at today. We will take a look at the code. So the stop order, it is the same stop loss or take profit order that you know from centralized exchanges, where you can define a threshold at which the order will be executed, so that when the price of the asset reaches the threshold, you buy or sell this asset, right? Another thing is bridge, also cross-chain lending, cross-chain oracle, liquidation protection. We've talked about this stuff on the previous workshop, so I won't go into much of detail today. Okay, so this is the setup of an automated one-step swap. I've talked about it on the previous workshop. Today, I will just touch upon it. So basically, it consists of 2 transactions. So the first one is two actions, so to say. So the first one is number 1, where an EOA, which is in the top left, approves the funds to be spent by the callback contract. And then number 2, 3, 4, 5, 6. This all is executed automatically by Reactive Network, but basically what it does, it executes the swap after the funds have been approved to be spent by our callback smart contract. All these words, Reactive Smart Contract, callback smart contract, will make more sense to you after we take a look at the code as well. But I also wanted to show you the scheme so that you have the graphical picture for the code that we will be discussing later, because it makes it much easier to wrap your mind around. Okay, so we have a bunch of live examples already. Flexi loan, which is basically a loan where a flash loan where you don't need to transfer your funds to the pool, but you can just approve them. They stay in your account, and then when someone wants to take a loan, only then they leave your account, but they get back in the same transaction as for every flash loan. And then a reactor, which is basically an automation deployer. It allows you, for instance, to use the stop order mentioned earlier without the need to write or deploy code to deal with the code, basically, because this is the interface for you to use those reactive automations without the need to code. And also we are doing some more integrations with Smart Trust, Dextrade, QST, and QuickSwap. And basically the purpose of this program we are talking about today, the BUIDL with Reactive Network program, is to get your projects on board as well, to integrate Reactive Network with you, to help you extend your functionality with our automations, modularity, cross-chain functionality, whatever you might need. So I will be happy if you join this list here. Okay, so another concept I wanted to cover today, and this is basically the only complicated concept about reactive network, the only concept that differs significantly from Ethereum smart contracts, is the dual state of reactive network. So what you can see here, on the top of the picture, you can see origin and destination chains, the usual chains such as Ethereum, Polygon, and BNB. Then you can also see reactive network. It says system, reactive smart contract, RC1, RC2, RC3. And then you can see reactive VM1 and reactive VM2. So the dual state means that every reactive smart contract exists in two instances. The first one lives in reactive network, and the second one lives in a dedicated React VM. So every user, every developer who is deploying any of the reactive smart contracts, or basically sending any transactions to reactive network, they automatically have their own reactive VM with the address of their EOA, right? And every smart contract you deploy, it lives within your VM and in the reactive network. So there are two instances. And let me describe how those instances differ. So the list on the left describes the reactive VM instance. The list on the right describes the reactive network instance. The React VM instance is triggered by the events. So it is the one that actually executes the automations, the one that reacts to external events on usual chains, on origin chains. And the reactive network instance does not react to those events. Then the first one, the React VM instance, updates its state based on those events, and the reactive network instance updates the state only based on user actions, developer actions, where you trigger the functions of this smart contract manually, basically calling the functions in the usual way rather than it being triggered by events on some other smart contracts. So the React VM instance emits callbacks, so sends transactions to the destination chain, and the reactive network does not. The React VM instance cannot be triggered directly by calling the functions. So when you call in the functions of a reactive smart contract in a usual way, you basically interact with the reactive network instance rather than React VM instance. And then the React VM instance cannot subscribe directly, but it can subscribe using callbacks. We will show it later, and the reactive network can subscribe to events directly. So yeah, this might sound a bit complicated, but we will take a look at the code and it will make much more sense. And this slide we will discuss later. So now let's go to the code. You can do some of the following. You can try existing apps, React to Flex alone. You can deploy and try the existing code examples, which we are going to be doing soon. You can modify existing examples, which I recommend. So basically, when you build your reactive smart contract setup, I recommend that you clone the reactive demos repository, which I will be showing right now, right? Which you can find on our website as well. Yeah, so let's go to the code. Also, you can ask any questions in the Telegram. This is my own Telegram, but also you can join our chat. So the link is in the description to this video, as I have said earlier. Okay, so now let's go and take a look at some code, right? Okay, so this is the website of Reactive Network. Let me show you how to get to the code. Basically, you can see GitHub here. You can see a bunch of repositories. The one that we're interested in is this one, the first one, Reactive Smart Contract Demos. If you intend to build, please clone it. You can see some readmes here. So the readme in the root folder, basically to set up the repository. But the main stuff is here in SRC. You can see all the different examples. We will be talking about basic example and Uniswap stop auto example today. And you can see that it's all pretty well documented. So just by reading this stuff, you will understand this. And just by following these instructions, you will make this work. Now, let me show a bunch of other things on our website as well. So you can go to the docs and you can see all the information here. But what we will be specifically interested in today is this tab here, which gives us the information to connect to our mainnet and to our testnet. And you can also find React scan links here. So the React scan for mainnet you can also find on our mainnet main page. But today we will be working with Lasna React scan. Okay, so now let me share another window, which is my IDE. This one here. Yeah, let me check. Yeah, you should be seeing my IDE now. So I'm in the Reactive Smart Contract Demos repository, SRC Demos folder, and I'm taking a look at the basic example right now. It consists of 3 smart contracts. The first contract, the basic demo L1 contract, is what we call an origin smart contract. So the one that exists on the chain where we will be monitoring events, and we will be monitoring this particular event received here, right? So if you remember the picture, it was the one on the left, the yellow origin smart contract on the left. So the smart contract in the middle of the picture, the blue one, is this one, a reactive contract. We'll discuss it also. And the callback contract is the one to which we are sending transactions with which we're interacting automatically as a result of this automation. It's here. And also we have a README here. We will be following the steps to replicate this whole thing. Yeah, let me take a look at the chat. No, we don't have any questions yet. Please feel free to ask any questions. I will try to answer them in real time. However, I'm in a different window, so it might happen with some of delay. Okay, so let's take a look at the origin smart contract first. So here in our basic example, it's just a dummy smart contract. So it doesn't really do anything. It just has this function receive, a payable one. So whenever you send funds to this smart contract, this stuff here is executed. Basically everything that is being done, an event is being emitted, and then the funds are being transferred back. So as you can see, they're transferred back to the one who sent them, and in the same amount that was sent. And basically how it works, to trigger this contract, you send some funds to it, it emits the event and sends the funds back. That's all. Now let's take a look at the Reactive Smart Contract as well. So as you can see, it's inherited from this interface here and this abstract reactive here. We will take a look into that if you have any questions about that. But basically, whenever you create a Reactive Smart Contract, you are recommended to inherit it from our library, because it's here in lib, reactive lib, src, abstract demo. So it exists in this repository, and I believe it exists as a separate repository as well. However, you can implement all the same stuff yourself if you have some spare time, right? Now, what it does here, it has a constructor and a React function. A constructor sets everything up to work. So it has a service contract address, which is basically a system contract address that you can find in the network information. It has origin chain ID. So we need to specify which chain we're looking at. Destination chain ID, the contract that we are monitoring, the topic 0 of the event that we are monitoring, and then the callback contract address to which we're sending callbacks or transactions, or the one which we're interacting with. Call it how you want. Now here we basically just set up all the variables to successfully interact with the origin contract and the callback contract. And here we subscribe to the events of interest. So we subscribe to an event on an origin chain on this contract of this topic 0, and those 3 things here are ignored for now. So this happens in a constructor when we deploy the contract. And then this function is being triggered whenever such an event happens, an event that we subscribed to. So here we have an additional condition that we're checking. We need the size, the amount of this transaction to be more or equal to 0.001 Ether. This is basically for debugging purposes to make sure that the setup works, because like if we want to make sure that this condition is being checked correctly, we may send less Ether and see that it doesn't trigger the callback. And if we send more Ether, it does trigger the callback. So here we construct the payload of our callback. In this particular example, it's super simple. We just call the callback function on the destination contract, and we provide the 0 address as a second argument. We will talk about that a bit later. This is for authorization purposes, as mentioned earlier. And then the emit callback event, as I have said already, this is a keyword. So this is not just a usual event. This is an event that triggers the callback on the destination chain. So we have a destination chain ID here. We have a callback contract address here. We have a gas limit. And we have this payload, which specifies the function to be called and the arguments. So this is all about this reactive smart contract. Basically, it waits for the event, this one, to be received, to be emitted. So this received event is emitted. We see it using a reactive smart contract, and then we call a callback function on the destination contract. And the destination contract, and we also call it a callback contract, is here. Let's take a look at it. So as you can see, it's inherited from abstract callback, which also we recommend. It's also in the library. If you have any questions, please ask right now or in the chat, or just take a look at what is being done in those contracts. But yeah, basically what the our callback contract in this particular setup does, it only has this callback function here with a bunch of checks, and this callback function only emits a callback received event for debugging purposes. So we will be triggering an event on an origin contract. The reactive smart contract will be calling the callback contract, the callback function of it, and it will emit the callback received event, and we will take a look at Sepolia scan to see that it actually happened. So yeah, we've run through all those contracts. Now let's take a look at the instructions and follow them. So you can just read this same thing here. You can. It also has some links here, and we'll jump straight. No, not straight to instructions, because for the setup to actually work, you need to specify those parameters, environment variables. So I have already done that for most of them, I believe. And you just need to do that on your machine, be it Windows or Linux, so that all the commands that we run in here actually work in the expected manner. right? Okay, so let's start with deploying the origin contract. So this, okay, we have some questions. Oh, okay, we don't have questions yet. So let us run this command here. So it requires us to have the origin RPC, which is Sepole in our case, because we will be deploying a origin contract on a Sepole, Ethereum Sepole testnet, because today we're working with testnets, and we will be working with Reactive Lesna testnet. So this is the Sepole RPC, and this is my private key stored in my environment variables, which I won't be sharing on this stream and on any other stream as well, hopefully. Okay, so I'm deploying this contract here. Yeah, let me make sure that I have all the environment variables set up correctly. Yeah, no, I don't have. I need to specify the origin RPC. So I'm not showing it in my window now, but I'm creating a environment variable for this variable here. And I will use Lesna, Sepole RPC for that purpose. So just give me a moment. Okay, and now I need to, since this is Windows and this is not very convenient, unfortunately, but I need to restart my IDE for it to see my new environment variables. So I'll be doing this a lot today, unfortunately. Okay, let's try again. Now I have this origin RPC here. Yeah, we don't need broadcast for now. Oops, something didn't work properly. Yeah, it's just my... Okay, let's try again. Yeah, now it should be correct. Yeah, it's probably because I didn't update my Forge. So let me try to do it right now. My Foundry, yeah. Okay, and now let's try again. And let me check my environment variables again. Yeah, sorry, with Windows environment variables, it's always a bit of a hassle because you need to update them all the time. Yep, I don't have it here. Okay, I have it under a different name. I have it under name, yeah, reactive private key. Okay, now I need to have this here. I've created a new environment variable and we will be restarting my IDE again. Sorry about that. Yeah, and now it should finally work. Yeah, but this stuff not working in front of you might prepare you for the mistakes you might actually make and the problems you might actually face. So this is actually the very essence of our, yeah, sorry, I haven't shared the screen. The very essence of our workshop. So yeah, I believe you can see the screen now. So I've ran this command here after I successfully added this and this environment variables. And as you can see, it deployed the reactive smart contract. So as you can see here, it says deploy the basic demo L1 contract and assign the deployed to address from the response to origin address, right? So I need to take this thing here and add it to environment variables. Again, so I'm not sharing the screen as I have already said, but yeah, what I'm doing is I'm saving this as origin address. Okay. Now let's do the next step, which is the destination contract. It also will be deployed on Sepolia network. And additional thing that is important here is that we are funding it with a bit of money, some Ether here. So it has money to actually run the transactions because this callback contract will be charged by Reactive Network to execute the callbacks. Right, so this is a destination RPC, which is the same RPC as origin RPC in our case. So Sepolia RPC, destination private key to deploy the contract. and then the destination callback proxy address. So let's talk about this one. And for that, I will need to share a different window. And it will be this one. We will need to go to the docs. So we are in the docs right now. We need to go to origins and destinations. And we need this callback proxy address here. So currently we're working with Ethereum Sepolia. So we need this one here. And I will be saving it to my environment variables under the name of, let me show you, destination callback proxy address. Basically, it's the system, the system contract from which the callbacks are being sent. Okay, I've saved it in my environment variables, and I will be closing and opening this window again. And now I can run this command here. Thus, deploying the destination smart contract, the one that we discussed earlier, this one, basic demo L1 callback. So the compilation is successful, and now it's being deployed, and soon it will be deployed, and we will proceed with the third step. But as you can see here, we need to assign the deployed to address from the response to callback address, because this will be the very contract that we will be calling as a result of this whole setup. And we will need it in the third step where we actually deploy the reactive smart contract here. So let's wait for the transaction of Sepolia network to be mined. It takes some time, apparently. Meanwhile, I will take a look at the chat. Yeah, we don't have any questions yet, and we can wait for this thing here to be finalized. Yeah, let me take a look at Sepolia scan to see what's happening there. So this is my address, my test developer address, from which I'm usually deploying all those contracts. So you can see the contract deployment 5 minutes ago, but we cannot see the new one yet. For some reason, it takes a lot of time. I'm not sure it will be even finished, but yeah, let's wait for it to be finalized. This is weird. Let us take a look at Sepolia scan again, maybe the main page. So the last block was 8 seconds ago. So yeah, the Sepolia is working as expected. Maybe it's just I didn't provide enough money or something. Yeah, we just see the previous contract creation. Yeah, let's maybe try it again. Okay, yeah, let me show you. I don't know why it didn't work for the first time, but it did work the second time. Yeah, so you can see that I ran this command here. Yeah, this one here, right? And we have the deployed to address now, which we will be saving to our callback address environment variable. So I'm doing it behind the scenes because I'm only sharing my IDE screen for now. And this is the last time, hopefully, I'm opening and closing this window. But yeah, I really need to do it each time I create a new environment variable so that the terminal context knows actually about it. Right, and now we can finally deploy the Reactive Smart Contract. So yeah, I believe you can see it here. So you can see the Reactive RPC here, the Reactive Private Key here, the system contract address, the origin chain ID, destination chain ID, origin address. This is the topic 0 for our, yeah, as you can read it here, for our received event that we are monitoring. This is the topic 0, and this is the callback address. So let's deploy the Reactive Smart Contract. Yeah, I haven't updated my the respective this one here. Which one? RPC. It's the node RPC. Yeah, Reactive RPC. So yeah, let's provide it with the new one. So for the new one, we will go to stop sharing. I need to show it to you. We need to go to our docs actually, right? And Reactive mainnet, classnet, testnet. So we need this RPC here. And I'm saving it as Reactive RPC environment variable. I'm restarting my terminal. And I'm sharing the correct window for you to take a look at. This one here. Okay, now we can run this command and hope for success. Yeah, let me check those environment variables again. Maybe I forgot something. Probably the, okay, let's take a look. System contract address. I have it. Is it the correct one? Yep, it is. This one here. Now, another one is Reactive RPC. We have Reactive Private Key. Yes. System contract address. Origin chain ID. Origin. Yes, I don't have origin chain ID for some reason. So let's create origin chain ID. In our case, it is Sepolia. And for Sepolia, it is 115511. You can find it on our origins and destinations list as well. Okay, origin chain ID here. Then destination chain ID. Destination, yeah, I need to create this one. Destination chain ID. The same one as previously because it's both Sepolia. Origin address we have and callback address we have. So now let's restart this window here. and run this command here. Okay, as you can see, the Reactive Smart Contracts was deployed, so we can take a look at it on Lasna React Scan. And the last step we'll be doing, we'll be sending this callback to our origin. We'll be sending a transaction to our origin contract, the one we are monitoring. We'll be sending some funds to make sure the setup actually works. So first of all, let me go to Sepolia Scan and take a look at our our callback contract. Let me actually share this window now. Okay, you can see this Sepolia Scan here. So this is the contract, our callback contract here. And also we can take a look at the, at the origin contract as well. Right, nothing here yet. And also we'll take a look at our reactive contract on React Scan. So we'll be in the middle. So as you can see, it does not have any Reactive Network transactions. It has one RVM transaction, and we will see more stuff here soon. So it's subscribed to this event successfully. Yeah, we'll need this one here. Now, let us send this thing here to trigger this whole setup. So we are basically triggering the received event on the origin contract that I showed earlier. Okay, now let's take a look. So Sepolia Scan does not see it yet. Obviously, it takes some time. But yeah, what I've done here is I've sent some Ether to our origin contract address. Let's give it a bit more time. It's basically probably an issue on the Sepolia Scan side, right? Or no, it is an issue on my side because I'm looking at a different contract. We need this one here. Yeah, so 48 seconds ago, we've sent some funds, as you can see. And let's take a look at this transaction. We can take a look at the logs. And this is our received event that we triggered, right? So this is great. We can see this event here, and we can also see it here, this one. Now, let's go to the reactive contract and React Scan, respectively. Yeah, as you can see, it has a reactive transaction here 1 minute ago. Origin is Sepolia network. So yeah, let's take a look at it. It has all the information here. So my address, some other stuff, the destination transaction, and the origin transaction. So the origin transaction is the same that we've just taken a look at. Let me show it to you again. So this is the origin transaction. with this received event, right? And this is our, let me close this one here. And this is our destination transaction here on the destination contract with callback received event. So what happened is we triggered manually by sending some funds this event here. The Reactive Smart Contract that was subscribed to this event caught this event, called the callback function of the callback contract, and the callback contract, the callback function was executed, and thus the callback received event was emitted. And you can see that it actually worked. The last thing I wanted to share is, let's take a look actually at the destination contract. So we need this address here on Sepole scan. If you take a look at the callback contract, you might have an impression that nothing happened here, but it has one internal transaction. It shows it as an internal transaction because it was sent from a callback proxy contract, and thus it is considered to be internal by Sepole scan, by Etherscan. So we need to go to internal transactions, and here we will see this transaction that I showed you earlier that has this callback received event. And this is how Reactive Smart Contracts work. This is the simplest setup, but this is the basic workflow where you react to events on one chain with some actions on the same or different chain. So now let me take a look at the chat to answer any questions you might have. I don't see any questions yet. I will wait here for a few more minutes, answer the questions you have, and then we will wrap it up. I also wanted to share something about a stop order today, but we don't really have time for that because of all the hassle with environment variables. But if you're interested, please let me know in the chat. We might have another workshop if you need. But also you can check our YouTube. We have a bunch of workshop before, and we have already shown this stuff, and you can try it yourself. So yeah, this is probably everything I wanted to share today. I don't have any more to share. We don't have any questions in the chat. So basically that's it for today. Thank you very much, guys, for taking a look at our program, BUIDL with Reactive, and for joining us today in this workshop, be it in real time or recording. Please join our chat, ask questions, build, take a look at the docs. So join us in any way you want. It's been a pleasure, and have a great evening. Take care.